Hi guys, tonight's video we will be looking at ellipses, which is a continuation of the conic section. So what's an ellipse? An ellipse is a set of points such that the sum of the distances to the two fixed points is constant. What are these two fixed points I'm talking about? These are the focus points, which plural for focus is foci. So we're told that from any point on the ellipse, if we sum this distance and that distance, which is the first distance to the first foci and then the distance to the second foci, then that distance is always constant. So it doesn't matter. We can move this point right here. And again, distance 1 plus distance 2, whereby distance 1 goes to the first foci, distance 2 goes to the second foci, will always be constant. These are some definition terms that we need to remember in order to mathematically speak correctly in the section. So first of all, we see the center here, and after the center, and then we've got major axis and minor axis. So notice that the major axis is always the larger one, and then the minor axis is the smaller one. What lies on the major axis is those foci. So the focus points, we've got one here in red and the other and the red also, and then the vertex also lies at the end of the major axis. On the minor axis, we just have at the end there covertices, so a covertex and then a covertex. Another thing that we need to point out is the standard form of the equation of an ellipse. In this case, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. Notice that this equation looks a lot similar to the equation of a circle, but in the circle on the right side we had r squared, and then for the denominators we didn't have anything, so these were the a squared and b squared were non-existent. Okay, and then on the right side we have the general form, which we'll be looking at towards the end of the video. So I've got the same picture here, but I need us to note a few things. So the distance, talking about distance wise, the distance from the center to the focus will be called C. I think focus C, and then the distance from the center to the vertex will be referred to as A. So note that in this case, A is greater than C. So given that, why do I mention that? I mention that because the major axis can be vertical sometimes. It's not always horizontal, and what determines that is which value has the a squared, because a is the distance from the center to the vertex, and so a is always larger. So if we've got a under the x variable, that means that our ellipse will be horizontal because it will be along the x axis. If we have a switched over to come under the y, then this will switch around, whereby the major axis is now on the vertical axis, which is the y axis. So just keep those two in check. If you're if you have a situation where you have to determine is this a vertical or a horizontal ellipse, then the position of a will help us note where that is. So then the relationship and then I mentioned a as the distance from the center to the vertex, and then c as the distance from the center to the focus. Now b will be the distance from the center to the co-vertex, and those two are related by the focus length formula, which is c squared equals a squared minus b squared, which should be familiar from when we're talking about Pythagorean theorem in previous classes. So how do you, okay, for me, how I remember that it's a squared minus b squared equals c squared is that I remember, okay, a squared is the larger one. So in order to construct the whole thing, I've got, okay, larger minus smaller. So major axis, a squared minus whatever is left, which is b squared. So just keep this in mind. It will be very, very important as we move forward. Another thing that we need to mention is something called the eccentricity. So this is basically how we measure the ovalness of the ellipse. Notice that the ellipse looks a lot like an egg. So we can use this concept of eccentricity, which is given by the ratio E equals C over A. C is the distance from the center to the focus, and A is the distance from the center to the vertex. So if we take small divide by larger, we get a number less than 1. So if C over A is super small, like 0.0001, then that will tell us that our foci or our ellipse is more round, which means that the foci are really close to the center. And if we get that this number C over A is closer to 1, then that will tell us that the ellipse is more oval, which means that the foci are very close to the vertex. Now again, keep in mind that the eccentricity number is normally less than 1, but always greater than 0. Let's get into examples. So graph the ellipse and find the eccentricity. And how do we do this? Pause the video, try it, and then I will talk about it in the next slide, okay? All right, I went ahead and tried it. So the first thing I do is I need to locate my center. I hope you guys located your center as 1, -3. If not, ask me questions in class. And then next thing I ask myself, where is the major axis? Well, the A, which is the larger denominator, was under the X variable, which means that this is an ellipse which is along the horizontal axis. And that means it's a horizontal ellipse. And then from the center to the vertex, I've got that distance A. And then from the center to the foci, I've got the distance C. Next up, I know the values of A and C and B. So the next thing that I need to do is just, find the center, count distance A on the major axis, count distance C on the minor axis, and try to draw an ellipse. This was a really bad one, so I went ahead and did it on a software that looked much nicer. Okay, and then the eccentricity, what did you guys find for that? C over A. We've got the C value as, we've got to use that formula. C squared equals A squared minus B squared. And that will give us C, and we already know that A is 5, and so we just divide C over A, and we should have the eccentricity value. The next example is write the equation of the ellipse. We are given vertices, and we're also given the foci points, and in order to find the equation of the ellipse, this will be the standard form. Pause the video and have a try at it, and then we'll talk about it in a few minutes. So by now you should have tried that example, so we can just compare what we found. So I started out by just jotting down what the standard form of the equation of an ellipse is, and then just a reminder of what the distances are called. A is the distance from the center to the vertex, C is the distance from the center to the foci, and then B will be the distance from the center to the co-vertex. And then the formula that relates all those three distances, C squared equals A squared minus B squared. I did this because I needed my B term, or my B squared term, because notice in the standard equation, we've got we have B squared there. So I implemented this formula so that I could get the B value. So I went ahead and did all that, and I found B squared equals 5, so I have that. And then A squared, okay, so A squared is the distance from the center to the vertex. I don't know where the center is. That's why on the right side here, I used the midpoint formula to help me find where the center is. And we were given the distances of the vertices, so we know that the center is the midpoint of, from vertex to vertex. The midpoint is the center, so that's why I used the midpoint formula, and I ended up getting my center -1, -2, and I'm able to insert those for the H and the K. And then after that, given that I know where the center is and I know one of the vertices is, what I did after that was I just counted the distance from center to vertex to give me A, and then I squared it to give me the A squared term. So let me know what you found. I'll be checking the homework so we can talk about that. And then the last concept we need to talk about is how to change from the general form to the graphing form. So this form right here is the general or the standard form. So the general form is the expanded out form. So first of all, we need to group like variables and then move the constant and then factor out the leading coefficients of the squared term, because we need to complete the square of both variables, the x and the y variable. And last but not least, we need to divide out the constants in order to have this form where there's nothing in front of the x. Okay, so the only way to do it is by example. Pause the video and have a try at it, and then we'll talk about it in a few minutes. Hopefully by now you have tried it. I went ahead and tried the example on my graphing paper here. So first thing I did is I collected my x's on one side and I took over everything on the other side. So this is a y, went to the other side. This is a y, went over to the other side, and this is a constant, took it over to the other side. I completed the square for the x's, but first I needed to get rid of this leading coefficient. That's why I divide by 3. Whatever I do on the left side, I have to do on the right side. And after that, I have x squared plus 4x. I complete the square, and I find that that's x plus 2 squared. Notice I added a 4 and a 4. That was the step of completing the square for the x's. So I'm done with the x's. I need to repeat the process for the y's. So this is now irrelevant on my left side. So I took it over to the left side by simply negating it and bringing the y's over to the left side. And then I do the same process. Basically, I get rid of the leading coefficient, and then I complete the square for the y. And now that I have the square completed for the x and the y, I need to bring them together so that I can form, I can write, I can write the standard form of the equation of the ellipse. So I've got my x's and I've got my y's, but I still, I note that the standard form has that on the right side I have a 1. That's why I divide both sides by 9 so that I can change the right side to a 1. And there's some arithmetic involved here. 3/2 divided by 9. I just wrote out everything. That's how I like to do it. I write everything on the paper and then I rearrange everything to look nice and neat as the standard form. That's the video for tonight, and the practice is coming right up. Bye guys.